Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 7 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 416. Partition equal subset sum. Okay, so let's read the problem statement first. We have given an integer array nums. Okay, we have to return true if you can partition the array into two subsets such that the sum of the elements in both subsets is equal, or false otherwise. And this is constant size. Okay, nums.length ranging from 1 to 200 and nums of I is ranging from 1 to 100. Okay, now see this example number 1. This is my nums array. Okay, so here we are returning true. Why? Because this array can be partitioned as 155 and 11. Okay, and here you see, here we have some 11 and here also we have some 11. Done. So that is why we are returning true. Okay, and here in this nums we are returning false because the array cannot be partitioned into equal sum subsets. Okay, so let's suppose we have one nums array like this. Okay, and in that we have elements like this: a, b, c, d and e. Okay, and let's suppose the total sum is s. Okay, for this nums array. Okay, now if I divide this in two subsets, okay, in two subsets, and let's suppose here I have elements like a, b, c, and here I have elements like d and e. Okay, and let's suppose the sum of this is x and sum of this one is also x, right? So now we have to partition equal subset sum, right? So here let's suppose sum is same. Okay, so here in this case we are going to return true because we have two subsets having equal sum x and x. Okay, so here this x plus this x, if I do x plus x, so the overall sum, okay, is going to be equal to this s only, right? Because we are using all the elements, right? a, b, c, d, e, all the elements are there, and here sum is x, here sum is x. So if I add these two, I will get total sum s. Okay, and here I can write it like this: 2x is equal to s. I can write it like this: x is equal to s by 2. Okay, so that simply means that this subset is having half sum, okay, s by 2, and this subset is also having half sum. Okay, so here if we want equal sum both sides. Okay, so here if you see in this case the total sum is 5 plus 3 8, 8 plus 2 10, 11. 11 divided by 2, we are not going to properly split them, right? It is not possible to properly split the elements. Okay, we are getting 5.5 something like that. Okay, but this is not right now. We don't have this value, right? So we want equal values both sides. Okay, so if we have like 12 divided by 12, then it is possible now. 6 sum here, 6 sum that side, right? So here in this case also it is possible. Total sum, if you calculate 11 plus 10 plus 1, so you are going to get 22. 22 divided by 2 if you do, so in each subset you are getting sum 11, right? Here if you see, so first case is if the total sum modulus with 2 is not equal to 0. Okay, if we are not going to properly divide. Okay, so here see remainder is just 1. Okay, remainder is not equal to 0. Okay, here remainder is equal to 0. Okay, we are going to properly divide this complete nums in two subsets, but here proper split is not possible. Okay, because this is odd number. Okay, so if total sum modulus with 2 is not equal to 0, we are going to return false. Okay, this is one thing. Okay, but now it is not like this. Okay, so here what I'm saying, total sum, whatever total sum you have, okay, if you are not going to divide it with 2, okay, properly, so here that simply means total sum modulus with 2 is not equal to 0, then you are returning false. But this is not valid, that totals, if my total sum is properly divisible by 2, then we don't need to return true, then it's not sure. Okay, why it's not sure, let's see. So if you have, let's suppose elements like this 1 3 and 8, now tell me here 8 plus 3 11, 11 plus 1 12, so you are going to return true for this case? No, true is not possible here. Why? Because you can't split this in two arrays. Okay, if you split it like this 1 3 8, so it's not valid now. Here sum is 4, here sum is 8. Okay, there's no way, right? I can't create two subsets, okay, having equal sum. Okay, so but we know one thing for sure: if total sum modulus with 2 is not equal to 0, okay, if the sum is odd, then definitely is not possible. But if sum is even, then we have to check few more things. Okay, that's what I'm saying. So this is one thing. All right, now once this is done, okay, now let's draw tree diagram. Okay, for this one, we are getting true now. So 1 5 11 5, we have nums array like this: 1 5 and 11 and 5. Okay, so initially your I is here. Okay, so now here you have okay, so if in one subset you have some 11, okay, then definitely your other subset will have some 11 only, right? So total sum is 22. If I divide it with 2, I get 11. So if you find just one subset having 11 sum, then definitely the other one will have 11. Okay, so here what I will do, I will calculate any subset having 11 sum. Okay, so here let's suppose first your I is here. So your target is 11. Okay, you want to achieve 11, not 22 but 11. Okay, because if my one subset contains 11 sum, then definitely other one will have 11 only, right? So here you have two options, whether you want to take this or skip this. So if you want to take this, then your target will be reduced to 10. Okay, if you are taking it, then your target will be reduced to 10. Okay, if you are skipping it, then your target will again remain 11 only. Okay, so here you are taking, so that simply means that you have this one here. Okay, you are taking this. Okay, and here you have nothing. All right, and now next time this is your array, right? 1 5 11 5, and next time your I will be here. Okay, and same way here 1 5 11 and 5, and next time your I is at this position. Okay, now this is going to be very big tree. Okay, so let me solve just one part. Okay, one side. So here again you have two options, whether you want to take this element or skip this. Okay, so if you take this, then your target will be reduced to, which was 10, so it will become 5 only now. Okay, and here if you don't take this, then your target will remain what? Your target will remain on 10 only, right? 10 only. Okay, if you don't take this 5. Okay, so now here now in your subset you have elements like 1 5 here. Okay, and next time your I will be at this index. Okay, done. Okay, same way here you have just one here, and next time your I is going to be at 11 only. Okay, here, done. Now again if you see here in this side only, if I do this take or skip. Okay, so here let's suppose I skip this 11. Okay, let's suppose this time I skip this, then next time my I is going to be 1 5 11 5. So my I is going to be at this index, and my subset is still 1 comma 5, and my remaining target is still 5 only. Okay, still 5 only. I didn't take this. Okay, now here let's suppose in this part, if I take or skip. Okay, so if I take this current 5, okay, so then I will have this subset 1 5 5. Okay, and now the target is going to be reduced by 0. Okay, to 0 only 5. Okay, and we take 5 here, so it is going to become 0. All right, and next time my I here going out of bound, right? So here I reaches out of bound, right? So now here my target becomes 0. Okay, so in that case we have to return true. Okay, so if from any side it is possible to have some one subset, okay, where my target becomes equal to 0, then just simply return true. Okay, so from here return true, from this side we are returning true. Okay, from this side we are returning true, then from this side we are returning true. So overall we are returning true here. Okay, for this part. So this is nothing but a recursion tree diagram, right? Let's write the code. Okay, recursion and memo code for this one. All right, so let me just maximize the screen. So now first of all, a few basic things. Okay, so int total sum and set it to 0. Okay, and then just iterate over all the numbers that we have in my nums array. All right, and here just add those numbers in my total sum. Okay, total sum is going to become total sum plus this num. Done. Now here one basic check that you have to do: if total sum, and if I do the modulus with 2, okay, and if I don't get this remainder as 0. Okay, so in that case simply return false. Proper split is not valid. Okay, we can't split our nums array into equal subsets. This is done. Then what is going to be my target? So I told you that my target is going to be total sum divided by 2. Okay, 11. Okay, for that particular example number 1, right? And now after that, here let's use the boolean array. Okay, boolean memoization. Okay, we need the memoization in this problem. Okay, if you don't use this, then you will get the mem exceed error. Okay, so here new memo. Okay, so here for few cases maybe we are going to call the same tree again and again. Okay, so here you are calling this, okay, 1 5 11 5, and here at 5 you have two options. Okay, take or skip. So same way you are going to calculate that same thing here as well. Okay, in the further tree. Okay, so same part you have to again do na, take or skip. So if you already store the answer for this one, then it will be easy na. So that's the reason we are going to use memoization. Okay, so here what you are going to do, new boolean. Okay, and here you have to pass the length of nums. Okay, nums dot length. Okay, two things are changing, nums dot length, and my target is also changing every time. Okay, so target plus 1. Okay, so target plus 1, that simply means that we have target from 0 to 11, right? 0 to 11, right? So here I'm writing 12. Okay, 12 size. Why 12 size? Because 0 to 11 elements, right? So that's the reason. Then from here I'm just going to return can. Look at this method, can partition, partition, partition recursive. Okay, and here in this can partition recursive, I'm just going to pass my nums array, and then I'm just going to pass the index. Okay, and then I'm just going to pass the target, and then after that I'm just going to pass the memoization array. Okay, so this boolean memoization array. Okay, so here you have to write memo only. Okay, this is done. All right, so now this is done. Now let's write the code for this function. Okay, so here private boolean, and now let me just copy this complete. Okay, so here what we are passing, we are passing nums. Okay, nums array. So let's just copy this, paste it here, and we are passing the index. So here int index you can write, and then we are passing target. So int target, and then we are passing this memoization. Okay, so boolean memoization. Okay, all right, so now here inside this what we need to do, so if the target at any point it becomes equal to 0, then what you need to do, you have to simply return true, right? So target is equal to 0, then return true. Okay, this is one thing. Now if your index reaches out of bound, okay, so index becomes greater than equal to nums dot length. Okay, or your target becomes negative. Okay, with the addition of some elements your target becomes negative. Okay, so you need just 5 but you get -7 number, and you will become -2. Okay, so in that case we have to simply return false as well. Okay, return false. These are few basic conditions, and memoization we are using, right? So here if we already know the value, okay, where at this particular index, okay, and the same target. Okay, if for this part we have already solved in the past, okay, so if it is not equal to null, okay, then in that case we have to just return this. Okay, we don't need to solve it again and again if we have already know the value of this part. Okay, so this is done. Okay, now if we are including the current element, if we are including the current element and excluding current element, these two things we have to check now. So if we are including the current element, okay, so if, and here just call this, if we are including, okay, this is for including part. Okay, so if we are including, then here after that I will move to the next index. Okay, if I'm including, and my target will be reduced, target will come target minus nums of index. Okay, if I'm including, right? So if I'm including, okay, and if this condition becomes satisfied, okay, then memo of index and target, just memo of this index, okay, and the target, here just set it to true. Okay, true. All right. Okay, so if this becomes part, this part becomes true, then set it to true and simply return true as well. Okay, from here return true. All right, now if we are excluding, okay, so if we are excluding, then you have to add this in the memo of index and target. Index and target, okay, and here you can simply call can partition recursive, and here next time it is going to be index plus 1 and target will remain as it is. Okay, there will be no change in the target. Okay, and here memo only, and then you have to just simply return this. That's it. Okay, so this is done, and here you have to simply return memo of index and target. Okay, so now let's run the code and see if there are code issues. We'll try to fix that. So yes, there are some issues, so now let's try to fix that. Okay, be small, okay, make it capital. If you see, you are writing again small this. Okay, now again run it. Now all good. Now let's submit it. So let's see. So see, our solution is accepted, right, with this recursion and memoization approach. Okay, so now I hope that you guys are clear with this recursion and memoization approach. Okay, now after this I am moving to the DP approach. Okay, so this is code for recursion part. Okay, now in DP how we are going to solve this problem. Okay, so few basic things only. Okay, so you know that our target is 11. Okay, so first we are going to calculate the total sum. Okay, and then after calculating total sum we are going to check if total sum modulus with 2, if it is not equal to 0, then we are going to return false. Otherwise we have to further calculate. Okay, so here from here we are going to calculate the total target. So target is nothing but total sum divided by 2, that is 11 for example number 1. Okay, this is be new, right? Now we have to create a 1D array. Okay, boolean DP you can say. Okay, and in this size is going to be target plus 1. Okay, so now we are using 1D array only. So here at 0 index, 1 index, 10 and 11. Okay, until 11 we need the sum. Okay, so I'm going to create one DP array of size target plus 1. Okay, and here when we have empty subset, then definitely we are going to get true. Okay, so it is always achievable to get the sum 0 when we have an empty subset. Okay, and all the rest I am just going to fill it with false. Okay, this code is going to be very simple. Okay, dp1. Okay, 1D array only we are going to use. So all this I am going to set to false. Only first one which is set to true, because with an empty subset we are always going to get this sum 0. Okay, now after that just single loop. So here we have to iterate over all these elements one by one. Okay, 1 5 11 and 1 5 11 and 5. Okay, so first time let's say you are going to pick this number. Okay, this number, then you have to run one j loop. Okay, and that j loop is going to start from this index 11. Okay, because last time we are going to get 11. Okay, until 11 we have to check. From 11 it is going to run to greater than equal to this number. Okay, so 11 to 1 we have to run this j loop now. Okay, first we are going to pick this, then we have to run j 11 to 1. Okay, so here this is nothing but 1. 11 to 1 we have to run. Okay, so here see, uh, here only 1, right? So definitely if the with the addition of 1 we are not going to achieve this 11 10 9 8 7 6 5 4 3 2 we are not going to achieve. Okay, with just addition of this one. Okay, so right now if I want to check a dp of 1, so this is false, right? This is false. Now here I know that if I write it like this, okay, with this it is not achievable, right? With this, okay, so here you can understand it like this. So I want to get this. Okay, this value. Okay, this is not achievable right now. This value is not achievable right now. Let's suppose you can say this is dp of j. This is not achievable right now. Okay, because false value is there, right? False value is there right now. But can I achieve this if I start from previous? Okay, from here if I start. Okay, so in this if I add this, okay, So here what I'm saying, so j minus the num value, okay, j minus num, which is nothing but this is nothing but dp of 1, okay, so this is nothing but dp of 1, okay, and this is nothing but this is true, but this is why, because this is nothing but dp of 0, j is 1 and num is 1, okay, so this is dp of 0 true, okay. So now here what I'm saying, if from here it is given, why I'm saying that, so if in j minus num, okay, if in this j minus num, if I add num, okay, if in j minus num, if I add num, then what is the result that I'm going to get? I'm going to get dp of j only, right? Right. So j minus num, okay, so if in this 0, if I add this 1, so I will get 1 only, okay. So through 0 this is possible, right? Right now it is not possible, but if in 0, okay, if I add 1, okay, this is a new number that is coming right now, okay, initially it is false, but in this 0, okay, in this path, in this 0, if I add this one, I am able to achieve it, okay. So here I'm just going to mark it true, okay. So here actually what we are going to use, we are going to run one loop, okay, j11 to 1, and here I'm just going to check, here I'm just going to operate my dp of j as dp of j or dp of j minus nums, j minus nums. So what it is saying, that from this path, okay, j minus num nothing but 0, okay. So in this j minus num, which is nothing but 0, in this if I add 1, so can I be able to achieve this 1? Yes. So that is why I'm just using or operation, okay. So this true false, so it is going to become true, yes, we are can achieve, okay. So now let's see some other numbers, then you guys will get much clear idea, okay. So this is for 1, so I update this true. Now let's take this 5. So now my j is going to run from 11 to 5, 11 to 5. So definitely with the addition of 5, definitely I want to be able to achieve 7, 8, 9, 10, 11, okay. So now let's check whether I can achieve 6, okay. So here you are going to write it as dp of 6. So dp of 6, if you write this formula here, so dp of 6 and 6 minus nums is 5, okay. So dp of 6 is equal to dp of 6 or or dp of here 6 nums is 5, 6 minus 5 1, okay. So here 6 is achievable, okay. So if in this, if I add 5, okay, new number, so I will get 6, okay, dp of 6 or dp of 1, okay. So here 6 I'm going to make it true, okay, clear. Why I'm setting it to true, because this dp of 6, we initially it is false, it was not achievable, but now it is achievable if I do the or, okay, if I add the number, current number, which is 5, with the 1, okay, with the 1, then this is our achievable. So here how we check 1, so in dp of 6 I'm subtracting 5 now, here 6 minus 5, right, this is 5 is fixed and here 6, so that is achievable, okay. So from 1, if I add 5, then 6 is achievable, okay. So this is one path, 1 to 5, 1 plus 5 6, okay. Now same way dp of 5 until 5 we have done, so dp of 5 is achievable. How it is achievable? So it is achievable, right now it is false, but it is achievable if I don't use 1, but instead of that, from here 0 only I make the jump to 5, okay. So here dp of 5 or dp of j minus this 0, okay. So that then it is achievable, okay. So what I'm doing here, clear, right, what I'm doing here. So I'm saying, see here, j is nothing but 5, 5 minus 5, so it was 0, and here if I add 5, then 5 is achievable, right. So here in this 0 I'm adding 5. Same way 6, okay, if I want to achieve dp of 6, okay, so j minus 6 minus 5 plus 5, then it is achievable, okay. Here 1 is coming and here 5, so then 6 is achievable, okay. So now I mark it, this has true, this has true, okay. Now 11, so 11 means 11 to 11 only one, okay. So here 11 can 11 is achievable, let's see. So here dp of 11, and here or dp of 11 minus nums 0. Yes, this is achievable. Okay, so in 0 only. Okay, initially it's empty now, my subset is empty, so 0. Okay, so in that if I add 11, then it is possible. So here I'm making it a true. Okay, this is true. Now again you have to check for this 5. Okay, then here this is 5, right? So again you have to check from starting from this 11. Okay, so now 11 is possible. Yes, 11 is already possible because it is already true now. So if it is already true, then you make it true. Okay, so 11 is possible. And also in this way also 155 if you use. So from here 0 to 5, then 5 1 to 5. Okay, see this uh, this blue color 1 to 5, and then again you add the new 5, then also it is achievable, but it is already true now. This part is already true, so why to check other things? Okay, so it is going to become true only. So this is done. Then again 10 is achievable. Yes, 10 is also achievable if you use just 5 and 5. Okay, so here from this 5, okay, then it is also achievable, so you are going to make it a true. 9 is achievable. 9 is not achievable, I don't think so. Then 8 is also not achievable. 7 is also not achievable, it is already true. Okay, and this is already true. That's it. Okay, so in the end here at this point this is true now, so you have to simply return true. Okay, that's it. So dp of target we have to return. Okay, if this value is true in the end, just true, just return it. Okay, so let's write the code for this dp approach. So same thing. Okay, very few things we have to change. So here this boolean, okay, single array we have to use. So here let me change it to dp. Okay, and here new boolean, and here you have to size, give the size as target plus 1. Okay, because here 12, total 12, right? 0 to 11, done. Okay, and initially you have to give dp of 0 because empty subset sum is achievable. Okay, so I am setting it to true. Okay, now this is done, and here just delete everything. Okay, this is done. All right, now very few things. Okay, code is very small. So now here for int, let me just maximize the screen a little bit. For int nums and run one j loop. Int j is equal to target. Okay, and j is greater than equal to num, and here j minus minus. All right, and here you have to update dp of j as dp of j or dp of j minus nums num. That's it, and you have to return dp of target. Okay, here you have to return dp of target. That's it. Let's use it some more. Okay, now let's run it and see if there are any code issues. So all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.